She graduated with a bachelor's degree and a master's in computer science from Stanford, where she created and taught the course TensorFlow for deep learning research. She's currently working on productionizing AI research at Nvidia. But when she's not teaching machines to understand human languages, she writes books and blogs. And her writings have been published in leading newspapers in the US, France, and Vietnam. Welcome.
Do you have a clicker? Do you have a clicker for the?
Also, better to stand here because the capture on camera.
Okay, cool. Hey, so today we're going to talk about machine learning interviews. So slides have been posted on my Twitter, Chipro, if you just want to look at it and follow along. And okay, so because my talk is about machine learning interviews and how to get a job in machine learning, so I figured I should talk a little bit about my background and how I got into machine learning. So I'm actually come from a writing background, so I've been writing since high school, and I published several books, and I thought that when I got to college, I thought I should just continue doing writing. But then I took some CS courses, I really liked them, and now I'm a CS major. I also worked on product management, so I got involved with 3 startups, and 2 of them got acquired, and 1 of them now is still active with 20 million monthly active users. So since doing machine learning, I taught a course at Stanford. I also work at startup Primer.ai, and I was at Netflix, and now I'm at Nvidia. So our team work on productize, building tools to help companies bring AI research into production. So we also publish papers because it's a process of developing techniques, toolkits. We come up with new algorithms. For example, so we have a paper in the speech, and we have several papers at workshops. So for my work, so we are so our team is extremely pro open source. So most of our work is published. So if you're interested, you can go into our GitHub. So for the talk today, we're going to cover 5 points. So the first is about different machine learning jobs. I think Josh yesterday had a great overview. So it's going to be quickly highlight a few points. Second is the different career paths into machine learning. The next is to try to understand interviewer mindset when you apply for a job, and then go over the interview process and the recruiting pipeline. So for machine learning job, so I think there's few points that I would like to just discuss a little bit further. So the first, the difference between research and applied research. So I think in terms of doing research, I see that two vertical, just peer research and applied research. So our team is applied research. So for research, I think it's to find. So of course, the definition is extremely debatable. So if you have something unclear, or do you think that you have questions, then feel free to stop me. So the first is research is to find the answers for fundamental questions and expand the body of theoretical knowledge. And applied research is to find solutions to practical problems. So one example of research could be to develop a new technique for transfer learning, and you test it, you show that it works on a very small data set like MNIST or CIFAR-10. And then apply research, okay, then how do I make the technique work for a real world data set? And you might want to scale it to 1,000 GPUs. So research focus on very long-term outcomes. So you don't, if you come up with a new technique, it might not be able to commercialize in in a decade, and it's fine for some companies. But when you do applied research, you prefer to have immediate commercial outcome. So the lines is very blurred because our team, even though our team is applied research, because in the process of developing techniques to bring those techniques into productions, you also come up with new techniques yourself. So you also publish papers, so our teams also do that. And especially in machine learning, I think the line is very blurred. First is because cutting edge research in machine learning is often led by companies, by very big corporations, with commercial goals in mind. So if you think of the biggest AI lab, if you think of Google or Facebook. And also in machine learning research, there is currently a lack of theoretical framework to explain techniques that work well empirically. So I feel machine learning research is very empirical right now. So the next thing is the difference between a research scientist and a research engineer. So a research scientist might develop original research ideas, And a research engineer is supposed to be somebody to help that research scientist to actualize this idea. And in machine learning research nowadays, because people do a lot move toward like bigger models using more compute and more data, so it's very important to have people with good engineering skills to scale those models. And it's a really, really hard problem, engineering problem. For a research scientist you might need a PhD to apply for a role in research as a research scientist, but as a research engineer, you don't need to. And it really depends on organization, but I have seen in many teams, a research scientist might act as an advisor for a research engineer. So research engineer can propose idea, and the research scientist is like, okay, that sounds reasonable, let's work on it. Also, a lot of people, like a lot of engineers, I see that they want to get into research, so they start as a research engineer just to learn how people actually do research, so that one day they can become a research scientist themselves. And again, it really depends from organization to organization and team to team. So if you see like one of the most, and in some organizations, there's virtually no difference. Some of the most influential papers recently, such as the GPT-2 paper and the Transformer paper, actually have both research scientists and research engineers as equal first author. And also there's another role like very generic, a machine learning engineer. So in a lot of startups or in a lot of like big companies as well, a machine learning engineer might spend most of their time dealing with data, like cleaning data, wrangling data, doing data, understanding data, and not enough time on like actual modeling. So we often ask me, so what's the difference between a machine learning engineer and a data scientist? So a data scientists extract knowledge and insights from data, and usually like a data scientist might use that data to help companies make decisions, whereas machine learning engineers like models. Machine learning engineers create models that learn from data. So machine learning actually part of data science. And machine learning engineers usually develop models to turn data into products. I think that's the biggest difference that a data scientist is a scientist. So engineering isn't a top priority. So they might not be a great engineer, but a machine learning engineer has to be a great engineer. I mean, it doesn't has to, like, it's good if they're a great engineer. So I think like for most of this talk, for machine learning engineer, we will refer to like research engineer, the developer relationship engineer for machine learning. Now you see like Google AI or Microsoft AI usually have this developer relationship engineers to just focus on a machine learning product. So it includes data scientist, deep learning engineer, and the generic machine learning engineer role. And it does not cover like machine learning depth of a framework engineer. I also want to highlight that machine learning at big companies is very different from machine learning at a startup. So it might be useful if you're looking for a job and consider which company is a good fit for you. So the biggest, a machine learning research is very expensive. So for the estimate cost for the unfast system of DeepMind can go up to like $26 million. And because machine learning research requires a lot of compute, data, and talent, not many companies can afford to do it. So only big companies can afford to do a research. So you can see that like recently you probably read news about DeepMind got into $1 billion debt, or OpenAI. OpenAI, they just raised $1 billion from Microsoft. So startup usually cannot do that. Also, big companies can afford to hire specialists and people who just focus on very small aspect of machine learning. First of all, somebody can be really, really good at building speech recognition systems, or like really good at solving paraphrasing problem. But as startups, usually startups, the development circle moves very fast. And sometimes today you might focus on this thing, and tomorrow you might focus on another thing. So startups prefer to have people who can do a lot of things and not just like focus on one thing. And as of hiring, I think big companies make a lot of hires, so they need to standardize their process to save their time. And as startups, they make less hires, so they need to make sure that every hire is good, so the process is more flexible and can be more adaptive to each candidate. So getting a job in machine learning. So I think like there are many different ways to get into machine learning. And I think this is some of the 6 most popular paths you usually see. So first is just like when you just like get a bachelor or master degree in machine learning, and then you get a job as a machine learning engineer at either one of those big companies or startup. So this is actually the path that I did. And because of the lack of machine learning focused degrees at universities, so usually you see this background from people who come from very big tech companies like MIT, Stanford, Berkeley, CMU, maybe Waterloo, Toronto. The thing is, the next one is like when you get a PhD in machine learning, and they become machine learning researcher. So for PhD, I think the names of the school also matter, but also what matter, the name of the school and the advisors matter, but what matter more is like whether you get the papers at top tier conferences. And after that, you probably join one of the big machine learning labs or one of those ML first startups like Element AI. So I think it's also very popular when you go from a data scientist, and then it usually happens because when the company suddenly like, have been working a lot with data science, and then nowadays like they decide that they need to use machine learning. So you have to make the transition. So you can get like on-job training. So you have to just adopt and learn machine learning to like build more machine learning models for using the same data. And I think another very popular one is a software engineer. Software engineer who want to get into machine learning engineers. This is pretty like how I see most of the candidates, because I think so how it happens is a lot of people who are only working as software engineers and are interested in machine learning, so they started either go back to school to take to do a master, or taking a lot of online courses or boot camps. So I think I have seen a lot of companies prefer this kind of candidates because they think that like it's easy to teach good engineers machine learning knowledge, but it's very hard to teach people in machine learning good engineering skills. So the next part is how to become a machine learning researcher. I think it's point back to like what Josh mentioned yesterday about how a lot of companies, it's hard to get enough talent from machine learning PhD. So companies are looking to hire from adjacent field, especially like from statistics or physics or math. So I think a lot of companies are willing to hire people like researchers from this field and then willing to train them on the job on machine learning. And also it's very common because some companies, a lot of people think of machine learning as a technique which can be applied into different fields. So it might be an option to get people from like very, very different fields and then teach them machine learning, and then so that can broaden the the range of applications in machine learning. So every single, almost like all the big companies that I know of have either a fellowship or residencies program, and they prefer recruiting people from very, very different fields, especially health, art, like architecture, even agriculture. So I think there are many different paths to get a job in machine learning. I just want to like emphasize that all those paths take a lot of time and there's no shortcut. And I see that a lot of people advertise online that he become a machine learning expert in like 10 weeks, which is like 5 easy steps. I don't think there's any shortcut like that. And if I were you, I would avoid all of them. So another thing is, depends on where you are in the career. You might looking for a job as a senior or a junior person might be a bit different. I talked to a lot of hiring managers told me that like for junior roles, for senior roles, so they need to hire that person for their like existing skills and expertise. But for junior roles, they like to hire for people who fresh out of college, they could prefer to hire them for attitude, like whether the person is willing to learn and willing to adapt to the team. A very big question people like ask me all the time is, do you need a PhD? And so see this like on a lot of websites, and these are just 2 of the messages I got who say like, I want to do machine learning, but I don't have a PhD. Can I do it? So I think it's also reinforced by like every single time I go to a conference or an event, I'm usually the only person who doesn't have a PhD. I think this might be the same case here. I think Chris might not have a PhD, but Yeah, so okay, so maybe this one not. But usually the most people you see at conference, like a speaker, have a PhD. So it might reinforce the idea that you need a PhD to do machine learning. But that's not true. So the truth is that like the only time that the only kind of roles that might require PhD is a research scientist or like applied research scientist. But this kind of role is make a very small percentage of the entire machine learning ecosystems. And even for many, even for the research scientist role, a lot of companies don't require PhD. For example, OpenAI doesn't require PhD for their research scientist role at all. And maybe because I'm an engineer, but I actually think that we need a lot more engineers in machine learning. So a lot of research, AI research right now is being open sourced. And if you look at their code, sometimes you just like don't want to read it because sometimes it's really bad. So I think it's really important that researchers get, the research teams get more engineers so that they can improve their own code quality. This could have like reproducibility and also like to help like bring this research into production. Okay, so I think the next time is to understand the interviewer's mindset. So I think there's just a few points. So like if you hate looking for a job, so companies also hate hiring. It's extremely expensive for companies to hire for machine learning. So for example, an agency, for a recruiting agency might charge like 20 to 30% first year salary for a hire. So just to pay for agency alone, it might be like $50,000 already for one hire. It's also very stressful for hiring managers. So like for a lot of companies have a strict headcount. So when a hiring manager get a headcount to hire somebody and they don't make a hire in time, that might look very bad on them. And it's boring for interviewers. Because imagine like you have a lot of you here probably like interview for the job as well, right? That's what I imagine. So like imagine you have like blocks a day to like do something, and then you just like have to take like an hour out of it to like ask questions to some people that you might never see again. And companies always say that they want the best people, which is not true. Companies want the best people who can do a reasonable job within their time and monetary constraints. So imagine you have two candidates. Candidate A take like 2 weeks and $10,000 to hire, and a candidate and that candidate A can do 90% of the job. But then you have candidate B who can maybe do like 93% of the job, but takes like 6 months and like $50,000 to hire. So company can pretty go with candidate A, even though it's not the best candidate possible. So companies actually okay with false negative. So it can be really good, but the schedule just doesn't match. Then you might not get hired. You would think that like when companies hire, they know what they are looking for, but that's not true. So especially in machine learning in Bay Area, because the competition for talents is so fierce, most companies hire before they know for sure, like before they're desperate. So if they're desperate, it's too late. So a company might like, okay, now we need some machine learning person. Like we don't know exactly what this person gonna do it. They might know for like the next few months, but not like a year or like 2 years. So they're like, okay, let's hire somebody, and the recruiter is like, okay, can you give me a job description and requirements? So that person's like, okay, let's just make up some like generic like requirements that they think that they might need. So a lot of time job descriptions are just for reference. You should just talk to the team directly to see like what they want. And unless you get referrals, if you just apply directly, so most likely the resume is going to be screened by a recruiter. And most recruiters don't have engineering background, which means that they cannot evaluate the technical skills. So when a recruiter looks at the resume, they pretty look for like weak signals to try to determine the level of competencies. And the strongest signals is like previous employers. So like, I could imagine that a recruiter sees that, oh, if you worked at Google or Facebook before, then you probably already passed the interviews, and you probably like learned some like best practices from those companies. Then also look at awards, papers, GitHub calculate on the open source project you've done, and referrals, and also degrees. Also, school names matter more when you're fresh out of college, but it matters a lot less if you have been on a job for a while. So I think this is a very informal survey. So I did on Twitter. So asking like people like what, like when they're screening resumes for machine learning engineer roles, like what signals they look for. And I think more than half look at GitHub and Kaggle, and only 10% chose like school names. And I would imagine, some people say that like a lot of people like to choose GitHub and Kaggle because it's the option that seems meritocratic, that it doesn't depend on like other things. But it's actually not true. So you could imagine, so past projects are not meritocratic. So not everyone can afford to contribute to open source project or do Kaggle competition because they take time. So it's usually like people who can do this open source project are usually people who have like free time. Like you go after work, you don't have to take care of like the children, you don't have to take care of like the parents, or you don't have to like very long hour jobs. So if we place too much importance on volunteer activities, then it might punish candidates who cannot afford to do volunteer activities. And I think I cannot stress this enough, like most interviewers that you encounter will be bad interviewers. The reason is that even at big companies, there's very little training for interviewers. So you go to, like you might be a fresh hour colleague, so you go to, so you get the first job, and then you shadow a few interviews, and then you start interview on their own. And I talked to a lot of interviewers, and they have no idea what they are doing. Everyone's like, I'm not sure I'm doing it right. I'm just like guessing if it's good questions. And and also like even senior interviewers can be bad interviewers, because I also noticed that like a lot of senior interviewers have pet questions. So like they ask the same question to every candidate, and then they like benchmark own candidates based on one single question. So an interview outcomes depend on many variables. So it can depend on like how much overlap of the skills of you and the interviewer have. Like because if you know computer vision really well and the interviewer doesn't know it, then the interviewer might think that you're an idiot. So or like it can depend on the mood. Like you might have a very stressful day, you didn't sleep enough, or the interviewer might just be having a bad day, and it can affect how they perceive you. So it is like an interview outcome. It is in no way a reflection of the ability or the self-worth. And a rejection is just a rejection, and you can do better next time. So companies know it too. So often, it's very common practice for companies to reach out to candidates that they rejected before to re-interview them like a year or so later. Okay, so for the interview process, so the interview process of machine learning pretty much evolved like out of the traditional software engineering interview process with some few added elements. It's pretty typical. Like the first is resume screen is usually either by a recruiter if you apply directly, or by the hiring manager directly if you have been referred. You have a phone screen, maybe one or two, and then coding challenges or take-home assignments, and then technical on-site offsite interview, maybe one or two, and then on-site interview, 4 to 8. Some companies actually do 8 interviews, which I think is a bit like excessive, but it happens. And so like highlights like. So I talked to a startup founder, so he's like Series A company who's like hiring aggressively, and he told me this. So his team has only one single female engineer, and he was asking me, like, I don't understand. I try to hire female engineers, but whenever I give them take-home assignment, they never return take-home assignment. Like only male candidates return take-home assignments. And I think it might be like take-home assignments also like another kind of like activities that a lot of people who have very busy at-home schedule can afford to do. So I hope that like hiring managers or recruiters keep that in mind when they give take-home assignments to candidates. So here's maybe a typical on-site schedule for machine learning. So most companies would send you the schedule with the name of the interviewers and their roles and like the kind of things that you should focus on. I think even if company doesn't send you this, it doesn't hurt for you to ask, because when you have the interviewers, you can actually look them up and see like what's the area of interest is, and you also get a sense of like what teams they might want you on. So actually, it's just I think like not every company sends a candidate, but also no companies has said no to me when I asked them for the schedule of the on-site interview. Okay, so I think I would like to go over some of what I call bad interview questions. So I think it's useful for candidates to like see like what bad interview questions for 2 reasons. First, the first reason is that questions are just proxies for interviewers to like try to evaluate your skill for the capacity, right? And if you have a bad proxy, you cannot make good evaluation. So when you encounter a bad question, you know it's a bad question, you might want to like just ask a few more questions to make sure you understand what the interviewer wants. And second, if you interview a company and you get too many bad questions, you might see it as a red flag. So it means that the company hasn't spent enough time thinking of their hiring pipeline, which means that they might make bad hires. And do you want to work at a company with whom that make bad hires? So the first kind of question is just like, the questions just ask for retention knowledge that can be easily looked up. So like just write down an equation, very complicated equations. Like if you're good, then maybe you can struggle a little bit and like struggle for half an hour or like an hour to come up with it. But then is this worth, is this the best use of the interview time? Because I think somebody told me this, I realized the saying like, if something can be easily acquired, it's not worth like testing for. So I think questions of very relevant skills. So I have had like candidates for machine learning researcher role have been asked to write a linked list. And it happens surprisingly like a lot of times. And I actually talk to interviewers who ask this kind of questions. And they defend their choice like, oh, because like you need to know whether the candidate can like actually write code. So this is based on the assumption that being able to write a good, being able to write linked list on the spot is a good proxy to evaluate like good coding skill, which is not true. Like most people who can write good linked lists are people who like in college or people who like spend a lot of time like preparing for like traditional software engineering interviews. They actually don't make good employees. Yeah. So I think like so the type of question is that like the kind of question whose solutions rely on like one single insight. So it's a like trick question. First of all, take the derivative of like h to the x. Like if you do chain rule, you can quickly realize it's not going to work. You just need a normal chain rule. So usually it has a trick here. I actually forgot the trick. Maybe it's why I don't like the question. But this kind of question is that like you either have seen the question before, then you say nothing about the ability. Or if you haven't seen the question before, then you might struggle for a long time and also say nothing about the capacity. And also like questions that try to evaluate multiple skills at once. So some interviews told me they like this question, like explain PCA to the grandma. But the thing is that like, it tests both skills. Like if a candidate struggle with this, you have no idea if this candidate doesn't know PCA or if you just don't know how to talk to grandma. I think that's the next question. The next type bad question, I think, is a question that is very specifically hard to remember names. So I think especially in machine learning, a lot of candidates don't come from the US. So they might have learned skills in different languages and have different terms. So they just throw terms like mob, Penrose inverse, or like Frobius norm. Then candidates might know what they are, but they don't know that they are referred in that case. So like, I would tell like interviewer, if you see candidates struggle when you mention the term, you should give them examples. And candidates like when you struggle with a question, you don't know what they're asking, you should ask like, oh, can you give me an example of what it is? And then you might recognize it. And it's the next is an extremely frustrating type of questions. So many companies like to ask this, many interviewers, they like to ask very open-ended questions. For example, like build recommendation system. So those questions are great in theories if the interviewers are also willing to accept open-ended answers. But the problem is that like a lot of interviewers only know one way to do things, and they expect candidates to come up with exact solution. And when the candidates start exploring something else, they go like, you don't know what you're doing, which is very unfair for the candidate. And the next is actually not exactly bad questions. They're only bad questions like further along in the process. So first of all, in the beginning, like easy questions might be good to screen out candidates. But like if you have moved on-site, it doesn't make sense for you to ask really easy questions. The problem is that like easy questions means that like if you can solve them, then it only means that you're not a bad candidate, but doesn't mean that you're a good candidate. And it doesn't leave room for you to show off like how good you are. So I would like usually encourage interviewers to ask like hard questions during on-site or like later round interview. So what makes a good questions? So here I just like prepare a few, like I think it's a good question. I would prefer questions that test for understanding rather than just like retention of knowledge. So first of all, like instead of asking you to explain k-means, a lot of people can say, okay, what k-mean is, and like you can pretty write out like simple algorithm. But do you understand like, what assumption k-means make, or like how could it work on different data set? So you can just like give them this data set, like okay, like if you apply k-means on the data set, like how would k-means work? And then you can pretty clearly realize that k-means will not work well directly on the data set because it makes some like several assumptions that the data set doesn't match. And also like really good candidate can also realize how to transform the data set into like different coordinates that like k-means can work well on. So another question is that like a lot of people know what's a named entity recognition system work, but also a very simple question is that like if you build a named entity recognition system, should you do like case sensitive or not case sensitive? So it's just a very simple question, but then you can show understanding of like what a system usually look for, like what value can like case bring to the system. These are questions I realized in the open-ended questions. So first of all, like a Duolingo is a platform. So do you guys use Duolingo? Okay. So it's a platform for learning language, right? So when you learn a new language, so Duolingo will recommend you like stories of increasing difficulty for you to read, right? So the question is just like how do you measure the difficulty of a story? Like how do you know that it's a difficult story or it's an easy story? And how would you like modify the story to make it easier or harder? So these are very open-ended questions, and there are a lot of ways that you can go. And also, I think a lot of companies, I think machine learning is very experimental. So a lot of companies also experiment with different interview format. So I've seen like several companies using multiple choice quiz. So it's more like very class inspired. So like you have, it's good for screening. So you can just send candidates a list of like multiple choice questions and let's see like whether they like meet the basics requirements. Instead of the quiz format, which I see at DeepMind, is that the candidates like, candidates spend like maybe 2 to 3 hours answering a lot of questions in succession. So just like throw questions at you and you just have to answer them like on the spot. A format I really like is code debugging. I see it at OpenAI, which is, so like the interviewer is gonna give you a piece of like buggy code, maybe a model that doesn't converge or something, and sit down and like walk them through step like how will you debug the system. So it's really relevant for machine learning engineer role. Another is a pair programming. So interviewers doesn't just ask you a question. The interviewer will also like work with you through the problem again. And when you're stuck, the interviewer can jump in and write the code for you, so it can get you out of the stuck, so you can move on. And another interview format I've seen at like I think it's at Apple and Element AI is instead of having one interviewer, you have 2 interviewers. And one interviewer is going to ask you a question, and the other interviewer is going to work with you to like solve through the questions. And I realized that format, I think having 2 interviewers actually increase the quality of the interviews a lot. Because when just one single person interview somebody, that person might have a bad day and they might not like try their best. But when you have like one of the coworkers like keeping check on you, then you really have to try their best. And also show like how you're going to work in team. Okay, so I think we'll just go through this very quickly because we ran out of time. So this recruiting pipeline, I think it's just like one of the started from my personal questions, curiosity. So I wanted to know 2 numbers. So the first is to like for my onsite-to-offer ratio. So many candidates ask me that, okay, now I get an onsite at Google. What is my chance of getting an offer? So I want to like the ratio, what's the conversion from onsite to offer. And also recruiters ask me, so like they want to know like if they give a candidate an offer, what's the chance this candidate will accept the offer? So the year rate. So I look at the biggest source of data that I can think of, like is a Glassdoor. So I collect almost 16,000 interview reviews from 27 major tech companies like Google, Amazon, Facebook, Microsoft, IBM. So for each interview, I get the result, which is like either no offer, accept offer, or decline offer. So experience is for my positive, negative, or neutral, and the difficulty levels and difficult, easy, or like medium. So of course, before I go further, I would like to say that this data has a lot of biases because very few people actually leave review for anything online. And those who do are usually compelled by either really good or really bad experiences. And also those who get offer or accept offer are much more likely to leave reviews than those who don't. But I was hoping that like even if the biases like are consistent across everyone, every company, then it's still useful like to compare across companies. And also the interview feedbacks like varies really widely, even if it's the same company. So first of all, here's the positive experience and the difficulty level for 5 different roles at Facebook. And you can see that like they are very different. Okay, so the first thing I found is that like the companies that have the lowest onsite-to-offer ratio are like Yelp, Google, Snap, and Airbnb. They're like very like the usual suspect. But what's surprising to me is that like the higher the onsite-to-offer ratio, like the more likely the offers are accepted. So it means like the harder to get in a company, the more likely the candidate is to turn down the offer. Which I thought about it more, I thought it makes sense. Because like if a candidate get an offer at like Google or like Airbnb, they probably have other good offers to choose from. And also these companies are also known as companies to make very good offers. So candidates might interview with them to get an offer so they can like ask the other companies to match. I also want to highlight that like companies with high onsite ratio offer doesn't mean that those companies are not selective. It might just mean that the company are more selective before bringing candidates on site. Because on-sites are very expensive for companies, so actually the higher the on-site offer ratio, the more financially sound the process is for them. I also look at how candidates are sourced. So if you look at this, so like most junior roles, candidates are sourced through either campus recruiting, which means they go to like campus career fair, or referrals, like for existing people in the company, refer their friends. And I think like there like a lot will talk about the important referrals, like from like YC to like I think Luca was supposed to be speaker here. So everyone said like referrals are like very, very important. So if you think about it, so imagine like if a company recruits from campus, it means that they probably go to a handful of very popular engineering schools. And then the people who are recruited from those engineering schools refer their friends. It means that like opportunities only come to people within that like several few engineering schools. So it turned like a lot of like big tech companies here into like some kind of like tech IB mixer. Like everyone is from like very popular tech school. So candidates ask me like, so what if you don't go to a fancy engineering school, or like if you don't know people who can refer you? So I guess there's only thing I can say, like just be so good they can't ignore you. So actually I have seen a lot of like recruiters go online, or even I myself, like when I spend a lot of time on GitHub, like too much time. But like usually when I see people make a very thoughtful pull request, and not only they really good code, but like also like very patient explaining what they are. Like if somebody can't, they're finding a good engineers who are willing to like, explain their code is like finding a unicorn. So whenever I find somebody like that, I was like immediately reach out to them like, hey, are you like available? Like want to chat or something? So or I can build a good portfolio, have a website so they can like show off the portfolio, do a calculation combination. I know it's time consuming, but it might be a good investment for the future. I think this also might not be important. Anyway, it's pretty obvious, like candidates with negative experience like are much less likely to accept offers. So if you have a positive experience, you might accept the offer like 80% of the time. But you have a negative like interview experience, then you accept it like only like 1/3 of the time. So it's a good reminder for companies that you always care about the interviewer, the candidate's experience. And here's just like several general tips. So I think what I really want to stress is that like the best time to interview is when you don't need a job. Because when you need a job, you're like very stressful and you're not yourself in interview. So it's good like even when you're already happy in the job, but you want to check out what's out there, or just to sharpen up the interview skills, then it doesn't hurt to just like do an interview with 1 or 2 companies. Okay, I think that's it. I post information on this book. So actually we're gonna book a machine learning interviews. And I have this information on my website and on Twitter. And if you have any questions, feel free to reach out to me. Thanks. I don't know if people have questions.
Yeah, maybe we have time for 1 or 2 questions, if there are any.
Huh? Actually, it can. So like one reason why I didn't work with a publisher is that I worked with a publisher before, and they would like to retain digital right to it, and I would like to have at least one digital copy available. Because I'm from Vietnam, and know that like maybe like $10 or like $20 might not be a big deal for people in the US, but it can be a big deal for people like from Vietnam or like for India. So I think the book could have like an online free version. And so if you would like to have like read an early draft and give me feedback, I would really appreciate it. Yeah.
How can we get access to it?
Huh?
How can we get access to that?
You can reach out to me. It's my email.
Okay.
Yeah, thanks.
I think I see you before.
Yeah. Do you have
Other questions?
What do you think about the evolution of this like signal processing? Because people kind of tend to prepare for the interview,
Yeah.
which makes the signals invalid with time. And I think it's a kind of constant evolving process of limitation game.
Yeah, so I think somebody told me this like, so it really depends on how you test for knowledge. If a question can be prepared for, then they're pretty not a very good questions. So I think that over time we could learn to look for things that really matter. For example, like past experience, past projects might be good signals. Or a lot of companies see that like they have like trial, like you can go, they give you a project to work on it and see whether you can maybe very short project, like maybe like only take 2 hours, but then whether you can explain every decisions you make in that project.
So tip number 2 on
Yeah.
your general tips slide,
Yeah.
you recommended that people go to interviews even if they're not planning to accept the job
Yeah.
necessarily.
Yeah.
How do you think that skews your data with respect to yield rates?
So I think this data is already very biased. So I think actually talk to recruiters, and the actual onsite-to-offer is slowly lower. It's like a few percentage lower, and the yield rate is like also like about like 5% lower as well. The actual one lower than what we see here. So I think of course if it was just like interview for fun, then the yield rate could be like much lower. But you never know. Like maybe like a candidate interview with you, and they really like you, and you make a really good offers, and even though they're not looking for jobs, they might just like switch.
Sure, sure.
Yeah.
Okay, thanks.
One last question. So, a lot of these are especially for people that are looking for jobs. But what general advice do you have for people that are looking for like more internship positions? They're not like full-time jobs, but
Internship. Yeah, I think I didn't mention it. Actually, I'm really glad you asked. So I think for internships, if you're looking for internships, I think it's a lot easier to get internship than to get full-time. So because of like interviews as such, are so noisy predictors, companies much prefer to hire people who they already know well. So like companies are much more likely to hire people who have interned with them before than people who they don't know. So interviews for internships are a lot easier. I would say like it's hard to quantify the difficulty level, but I would say like 3 times easier, like just by the number of like interviews you have to do, or the difficulty of the questions. And also like interns are a lot less a lot less responsibility, liability for companies. Like if a company hire a full-time, it's just so much overhead, right, with all the insurance and everything. And if you fire full-time employees, it's very costly for them as well. But then if you don't like interns, that person will leave after 3 months anyway. So it's a lot cheaper for company to hire. So company like to hire a lot of interns, and then if that intern does well, then it's gonna give them a conversion offer. So I would recommend like if you're still a student and you can afford to do internship, you should do as many internships as you can, just so you can collect a lot of conversion offers, and also like get a chance to experience like a startup or like a big company, or like maybe it's like a peer research lab.
Great. Let's thank Chip again.